Welcome to the video covering Chapter 4, Lesson 5, Slope. By the end of the lesson, we should be able to find slopes of lines. By definition, slope is a mathematical term for steepness of a line. We use the letter M to represent slope. It is calculated in two different ways depending on what information is given. We will look at how to find it from a graph when you are given a picture of the line, and then when you are given 2 points, which is just information from the line. Okay, so let's discuss finding slope from a graph. But before I actually show the coordinate plane and start doing our calculations, I want to discuss first this, this set of symbols here. This is the triangle that is the Greek alphabet letter delta. So in mathematics, that delta symbol actually means change in. So it's pretty much a subtraction, which we'll talk about later, but it's the change in y. So how is the graph changing in relation to the y-axis? How is the graph changing in relation to the x-axis? And what that looks like in terms that we normally use, the little simpler terms, is rise. Because remember, the coordinate plane, the y-axis is rising and falling. It's the one that's going up and down, the vertical line. And then in the x-axis, that change is described using the word run. From left to right, it's that horizontal axis. How is that x value changing? So you'll see this change in y over the change in x a little bit from me because it's just simpler to write a lot of the times than rise over run all the time. So just know that what this symbol means. This triangle means delta, which is change in. So now let's actually go ahead and take a look at the coordinate plane here. So if I just pick 2 points and make a line, counting the rise over the run is how we figure out the slope. And I really mean counting. So how many spaces does it take to go up and then over? And it is up and over. You want to make sure that you are rising. It's literally just the vertical move. That's the rise of 1, 2, 3, 4, 5, and we're going up, so it is a positive move. And then my run would be 1, 2, 3, 4, 5 again. So that is a positive move also. So in this example, this slope would be 5 over 5, which simplifies to 1. And so that's a quick example. Something to keep in mind is the direction. When you are going down, it is a negative move, and when you are going to the left, it is a negative move also. But at least in this example, because it is a positive line, then down 5 and then to the left 5, so this would now be down 5 and to the left 5, that still equals a positive 1. So you still get the same answer no matter which direction you go, as long as you are consistent, like up and to the right, down and to the left. Those 2 negative moves make it a positive slope, just like the 2 positive rise and runs would. Second, finding slope from 2 points is a formula. And the formula looks a little complicated because it has these little subscripts, so it's lower, these subscripts of 2 and 1. Please understand that in math, the subscripts are labeling things. So in this case, it's just the second y value minus the first y value, all over the second x value minus the first x value. So this represents here, these values should come from that same second point. These values here should come from that same first point. And then it is a subtraction in there, so you're going to want to be careful when you are subtracting negative numbers, just being extra careful with your work and not losing any of those negative symbols. Again, you'll see that I'm using the letter M because that's what we use to represent slope, and it's the change in y over the change in x, which, as I said, change is just a way that we use subtraction. Change is a difference. It's how something is changing. We use subtraction for that. So we're just plugging in the values and simplifying the fraction. Okay, let's go ahead and take a look at this example. We are finding the slope of this line. It is on a graph, so we're going to use rise over run. So you'll see here that I did this 2 different ways. The red work represents starting from this point and going to this point, and I just randomly picked these 2 points. It has to be nice points on the line. Pick any two nice points. So for example, I'm not going to pick this one here because I don't know for sure if it is actually in the middle. Same thing here. I'm not picking these points and I'm not sure exactly where they are. I'm picking these nice points. So this one looks like it's at -3, and then I picked 3, 0. So, but their actual coordinates don't matter because all I'm doing is counting. So I counted up 3, so that was a positive move, to the right 6, so it was a +3 over +6, rise over run. That simplifies to 1/2. In blue, I started over here and went down 3, and then to the left 6. The down and to the left is 2 negative moves, but they simplify to a positive number, so my final answer is that my slope is 1/2. One thing I'd like you to get from this slope being 1/2 is that means that even though we had to go up 3 and to the right 6, this answer is telling me that I should be able to go up 1 and to the right 2, and there's another nice point. Up 1 and to the right 2, and there's another nice point. So I don't have to count up 3 and over 6 every single time. This is a simplified slope, which means if I start at any nice point, I should be able to go up 1 and to the right 2 to get another nice point. This graph here, I picked the point 1, 2 and the point 4, 0, and counting in the red, I start up here and I went down 2, but then I went to the right 3. So it was down 2 and to the right 3. So a negative rise, a positive run. But if I go in the other direction and I start at this point, my rise is positive, my run is negative. So that would look like 2 over -3. Please understand that these are the same values. It does not matter where you put the negative symbol as long as it's only in one of these places. Because if you put it at the top and at the bottom, that simplifies to a positive like we saw in the last couple examples. So please get that this whole fraction is just negative. So you may choose to put that negative symbol directly in front of that fraction bar. Most of the time we just write it as -2 over 3, but please understand that's the same thing as a +2 over -3. So the slope of this line is a -2/3. Now let's look at some examples of finding slope using 2 points. So the first thing I'm going to do is I'm going to label these points with my little subscripts. So that's my first point, and this is my second point. So I'm labeling them with the little 1s and the little 2s, and they're lower, they are subscripted. They're not a power, it is not an exponent, so make sure they're floating a little lower. And so this labeling this way helps me plug things into my formula. So using the formula, y2 is -6 minus y1, which is +4, so -6 minus 4. x2 is 2 minus x1, which is -2, so 2 minus -2. Well, using your calculator preferably, so we're not making little arithmetic mistakes, we should get -10 over 4, which simplifies into -5/2. So our final answer is that m equals -5/2. Okay, looking at another example here. It's always nice to have the formula written in front of you so you know what you're referencing, and it's also nice to label your points with your little subscripts so that you know which ones go where in this formula. So based on that formula and how I've labeled my points, I'm going to do 3 minus 4 from 3 minus 4, and then on my x's it will be -4 minus 1. So 3 minus 4, -4 minus 1. Plug that into the calculator, I get a -1 over a -5, which simplifies to +1/5. You cannot leave your answer in this negative over negative form. You have to simplify it down to the +1/5. Now I'd like to give you some more information about slope that will really just provide a helpful check as to whether or not your calculated answer is correct when you are given a graph. There are actually 4 different types of slope, and so talking about the first one, this first one here is a positive line because it is going up from left to right, so this is going to give us a positive slope. The next one, if you happen to guess, is a negative slope. This one is going down from left to right. It doesn't matter where it is, it doesn't matter that this one's a little lower. This negative slope could be up here going like this. It's the fact that it is starting at the top on the left and going down to the right. So just keep in mind here that we read our graphs like we read a book from left to right. So this one is going up from left to right, and this one is going down from left to right. A positive and a negative slope are what you're going to see most of the time. However, there are often these special cases where this is a horizontal line going from left to right, where there is no steepness or slope to the graph. So the slope for this one is actually a zero slope. And for this, I always like to think about someone skiing. You can ski on these three examples. You can ski on a positive slope, maybe climbing up. You can ski on the negative slope, obviously going down. And this would be like a cross-country skiing. You're just kind of going on a flat surface, but you can actually ski. The final special case is the vertical line. This vertical line is not something you can ski on, at least not skiing on and surviving it. So this is actually a no slope or an undefined slope. So the big difference is like trying to switch your brain from thinking that none or no slope or none means zero. When it comes to slope, they are two different answers. A zero slope is a horizontal line, an undefined slope is a vertical line. So they are two different things. So positives going up, negatives going down, zero is a horizontal line, and undefined is a vertical line. Well, if you've been wondering how the concept of slope applies to our chapter on parallel lines, this is it. If you think about slope being the steepness of a line, you've got one line at this steepness, but a parallel line, in order to not cross it, also has to have the same steepness. So we'll see that parallel lines have the same slope. So as far as answering these questions, if the slope of line 1, again using these little subscripts here to label the slope of the first line is equal to 3, then the slope of the second line, if it's parallel to it, is also 3. If the slope of the first line is -4, the slope of the second line is also -4. If the slope of the first line is 3/4, then the slope of the line parallel to that is also 3/4. Perpendicular slopes are a little bit more complicated. If we have a line like this, and we know that perpendicular is supposed to intersect at a 90-degree angle, then if you look, my original line, the way we're looking at it on the screen there, has a negative slope. And if I put this line perpendicular to it, it now has a positive slope. So they definitely don't have the same slope. And the relationship is actually opposite reciprocals. So the opposite part means to make it positive or negative. So if it is already positive, you're going to make it negative. If it's negative, you're going to make it positive. And the reciprocals are when we flip a fraction. So if our original slope, or our slope of our first line is 3, well, that's 3/1. So to make it opposite, it's negative, and to flip it, it's now 1/3. If the original slope is -4, put that over a 1 to make it a fraction. It was negative, it is now positive, and instead of 4/1, it's 1/4. Positive 3/4 gets flipped and made negative. So these slopes would make perpendicular lines. So in this example, we are being asked to determine if lines are parallel and perpendicular. So in this case, we're going to look to see if they are the same slope or if they are opposite reciprocal slopes. And if we have either one of those things, then they are parallel or perpendicular. So given these points for P, Q, R, and S, we're determining if PQ and RS are parallel, perpendicular, or neither. So let's set it up. We need to find the slope. PQ is going to use this formula. Because we're given 2 points, I'm using that formula. We end up with a positive 1/2 slope. RS uses these 2 points and the formula, and we end up with a positive 1/2 slope. Because 1/2 equals 1/2, those two lines are parallel. Now in this example, we're given vertices A, B, C, and D of a rectangle, or we're going to check to see if it is a rectangle or not. And in that case, it's often helpful to actually draw this on a coordinate plane, just so that we can recognize maybe like which lines or which points we're going to be pairing up to figure out if they're parallel or perpendicular. So on a coordinate plane, A, B, C, and D are set up as as it looks, and it is a bit of a slant, so I'm not 100% sure about parallel or perpendicular, but we're asking to figure out if it is a rectangle. AB should be parallel to DC, and AD should be parallel to BC. That's what makes a rectangle a rectangle. And not only that, AB should be perpendicular to AD, and AB should be perpendicular to BC. And if they're perpendicular up here, then they will also be perpendicular down here, and that's something that we learned in a previous lesson. So let's start first with the parallel relationship. When we're looking at AB and DC, I have my work set up here using the points from AB, setting up using the formula, DC, so using these 2 points here, setting up using the formula, and we get positive 1/4 for both of them, so they are parallel. And so this is the relationship between AB and DC. So now let's look at AD and BC. So when we look at those, looks like we also get a yes here of a slope of a -4. Again, using A and D and using BC in our formulas, slope of -4 for both of them. So yes, they are parallel. So when we begin to now look at perpendicular relationships, well, we already did the calculations for the slopes of the 4 lines that are created here. We just have to compare them differently. So now I'm going to compare AB to AD. Is 1/4, are 1/4 and -4 opposite reciprocals? And the answer is yes. One of them is positive, one of them is negative. One is 1/4, while the other one is technically 4/1. So they are also perpendicular. So is ABCD a rectangle? The answer is yes, because of the relationships that we've proved with their slopes. This concludes the video lesson for lesson 5 on slope, of parallel lines specifically, but how do we find slopes of lines? We use either the slope formula or rise over run depending on the given information, also keeping in mind how it applies to parallels, which is that they have the same slope and perpendiculars have opposite reciprocal slopes.